Hello, everyone, and welcome to today's webinar, CTS Essential 8 Medium, Transition Your PSC Research to the Clinic with Confidence. I'm Alexis Krauss of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Thermo Fisher Scientific. To learn more about our sponsor, please visit thermofisher.com. Now, let's get started. Before we begin, I would like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, click on the Support tab found at the top right of the presentation window, or report your problem by clicking on the Ask a Question box located on the far left of your screen. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located at the top right of the presentation window and follow the process to obtain your credits. I now present today's speakers. Lauren Sangenario, Scientist, Research and Development, Cell Biology, Thermo Fisher Scientific, and Joanna Asprer, Product Manager, Cell Biology Life Sciences Solution Group, Thermo Fisher Scientific. For a complete biography on our speakers, please visit the Biography tab at the top of your screen. Lauren and Joanna, you may now begin your presentation.
Good morning or good afternoon, everyone, depending on where in the globe you are. Thank you for joining us on this webinar. My name is Joanna Asprer, Product Manager for Pluripotent Stem Cell Culture. And as mentioned earlier, with me today is our scientist from Research and Development, Lauren Sangenario. Today we will talk about pluripotent stem cell-based cell therapy, more specifically looking at how we can support work in this area with a variety of cell therapy systems or CTS products, most recently and most notably CTS Essential 8 Medium. I'm sure you are well aware that pluripotent stem cells, or PSCs, hold tremendous potential for cell therapy with their ability to self-renew and differentiate into many cell types of the body. According to this reference, many researchers around the world recognize that and are working to realize that potential through various clinical studies using iPSCs. And perhaps you are already involved in one of these studies, or perhaps you aspire towards joining these ranks. And in any case, I hope that today's presentation will help you realize the potential of PSCs in therapy. For my section, I will talk about cell therapy, some considerations in choosing reagents, and how we can help. I will briefly introduce the GIBCO Essential 8 Media System and go on to describe how CTS Essential 8 Medium is based on Essential 8, but it is more appropriate for cell therapy. I will then introduce and assemble the compatible products in a workflow that gives you the best support for your PSC-based cell therapies. And just a quick note, in her section, Lauren will show you the data relevant to items number 3 and 4. With that out of the way, my first point is the single most important point that I would like you to remember from this talk. When you think of cell therapy, reagents are no longer just reagents. When you're doing clinical research, or even when you're doing translational work, planning out what will eventually be used in clinical research and beyond, you have to think about reagents in terms of how they would touch or influence a therapeutic product. As such, in a cell therapy mindset, reagents become ancillary materials. How are they different? Ancillary materials are materials used in the manufacturing process but are not intended to remain in the final product. And this includes things like culture media. Although they're not present in the final product, they are essentially raw materials. In fact, that's how ancillary materials are referred to in Europe. So all the things you think about when it comes to raw materials, you do have to consider here. Is it safe enough? Is it pure enough? It matters because materials used during processing could influence the performance of a final product. It also matters because it's possible that some of this material could still end up in the finished product even if you don't mean for it to. Now, because ancillary materials are critical to the quality of performance of cell therapies, there are many direct and indirect regulatory guidances on the choice or use of ancillary materials. And here you just see the main regulatory guidance documents across the different regions. We're not going to go through each of them, but the point here is that reagents in cell therapy do need to be reviewed with different lenses than in basic research. They are regulatory lenses, and it may be slightly different lens even depending on your strategy. For example, where do you intend on developing or commercializing a therapy? So, the materials you use are considered as reagents, raw materials, ancillary materials. With that in mind, what do you consider when choosing what to use? First and foremost, of course, you want a high-quality product that performs well. Next, because this is a raw material used to generate therapies, of course, you want it to perform consistently. Next, thinking about a raw material more practically, you want to make sure that you have a stable, reliable supply that supports the continuity of your work. Not only that, but also you want to make sure that your supplier is able to accommodate your increased need for that material once you scale up for clinical trials and beyond. And next, as an ancillary material that touches the cells that eventually become a therapy, you want it to be as safe as it can possibly be, and very much related to that, you want it to comply with the relevant regulations. Next, and this is not something that we've touched on yet, but you want to make sure that you actually have rights to use the material for commercial purposes. Not all products grant that, and yet that is most likely what you will need if you were to bring your PSC work to the clinic. And finally, if you're not using the exact same reagent from start of development to the end, then you should consider a reagent or a set of reagents that give you a clear path from bench to the clinic. And we'll talk about that a little bit more later. But clearly, there is a lot to think about when choosing ancillary materials. And many of these considerations are not as simple as we'd like them to be, as you saw with just the variety of regulations to consider. And moreover, at the translational stage, many of these might feel like distant concerns, and it would be tempting to really just, put off thinking about them at all. However, the earlier you think about it, the better, because you can choose the right reagent during development and have a smooth path to the clinic. In the alternative, non-ideal scenario, you might develop the therapy with one reagent and prepare for a regulatory filing years after to find that the supplier can't accommodate your increased volume, or you don't have commercial rights, or there are regulatory concerns with your choice. Maybe formulation was not appropriate for cell therapy, or the QC testing is lacking, or documentation is lacking. In any case, you'd have to account for the extra effort and cost, either rectifying the issues with the current reagent, if that's even possible, or switching to a more suitable reagent, and all the redevelopment and comparability studies that might entail. Again, not the ideal situation, but the good news here is that we can help you with a number of the considerations up front. On the first point, we have over 30 years of experience manufacturing products under CGMP, or current good manufacturing practices. This is true across multiple manufacturing sites and across a wide variety of products, including most of our research use only, or RUO, media, along with our cell therapy systems, or CTS, products. What that means is that our manufacturing sites are registered with the FDA and are certified to certain ISO standards. The rigorous practices we adhere to at these sites ensure the consistency, reliability, and high quality of a wide variety of PSC workflow reagents. I'd like to point out, as an example, all GIBCO PSC culture media, whether RUO or CTS, are GMP manufactured. On the second point, the same long history, experience, and that scale across multiple sites enables us to provide you with reliable supply and to continue supporting you even as you scale up your own operations. Now again, up to this point, since this has to do with our company and our sites in general, this is true for both RUO and CTS products. As we continue down the list of how we can help you, you'll start to see more of the differences between RUO and CTS products and why CTS products provide the best support for cell therapy needs. We'll start with safety. CTS products are specifically intended for cell therapy and as such undergo extensive safety testing at QC. And all of that safety testing, as well as raw material information pertinent to safety, can be found in our Certificate of Analysis and Certificate of Origin. Next, regulatory compliance. We have experienced technical, quality, and regulatory teams to help us understand the direct and indirect regulations that I mentioned earlier. They help us design our CTS products so that we can minimize regulatory risks and aim to satisfy regulatory requirements. They also collect and curate regulatory and traceability information that can be very challenging to do. And then they funnel this information into a more readily available set of documents, such as our Certificate of Origin, and often also drug master files to facilitate your regulatory filings. Finally, the same experts become resources that do provide CTS customers with support to avoid pitfalls in their path to the clinic. Next, commercial use rights. We provide guidance and support for the commercial use of CTS products. In fact, CTS products typically carry the intended use statement for research use or manufacturing of cell, gene, or tissue-based products. Finally, we have seamless transition. We understand that you may start your research with, quite sensibly, a research use product. What we have are CTS products that have the same or similar formulations as our RUO products, except making the formulations Xeno-Free or animal origin-free to reduce risk and variability. As such, you can start with the RUO product and know that when the right time comes, you can easily switch to a CTS version. So these are the different ways that we can help, and in fact, we have helped quite a bit. Our products have been used in more than 100 cell and gene therapy clinical trials to date, and beyond that, several of our products are used as critical raw materials in commercialized cell and gene therapy manufacturing. So you can trust us to be your partner in bringing your own PSC-based therapy to the clinic. Now let me switch gears here to specifically talk about the Essential 8 media system and how we can help you here. Essential 8 medium is a feeder-free and xeno-free PSC medium that uses the Thomson Labs E8 formulation. The medium kit is comprised of a basal medium and a supplement, but it's named Essential 8 because altogether it contains only 8 components that are critical for growing PSCs. This is the key reason that many researchers have adopted Essential 8 medium. 8 components means less sources of variability compared to other media that typically have a lot more components. 8 components also means that it is more cost effective and therefore more scalable than other more complex media. And again, like all Gibco PSC media, Essential 8 is GMP manufactured. For a clearer view of what I meant in the previous slide, the table on the left shows a comparison of a more traditional medium, M-teaser, versus the 8 essential components in this media system. There's a clear difference in the number of components, of course, and as stated below in the quote, because it is so simple, it can be made in a more controlled way. But one striking difference in the formulation is the presence of BSA in M-teaser and the absence of either BSA or HSA in Essential 8. That's important because BSA or HSA, for that matter, is animal origin material and is a source of variability as well as a potential source of adventitious agents. So Essential 8, with the removal of BSA and the recommended use of a defined animal origin-free substrate like vitronectin, provides a good foundation for a cell therapy grade medium. And it's not just because of the formulation itself. It also helps that we know that it works really well. We know it supports classic PSC morphology, normal karyotype, high PSC marker expression, and trilineage potential over many, many passages. It's been tested in well over 100 lines, and at this point has been cited in over 600 different publications for a variety of PSC applications. For a while now, we have offered different versions, variations, or combinations in the Essential 8 family of products. Always, of course, trying to provide the product that is right for our customers no matter what it is that they're doing. Apart from Essential 8 for PSC maintenance and expansion, there's Essential 8 Flex with stabilized FGF2 activity for PSC maintenance with a flexible feeding schedule, or you can combine either of those media with Revitacell supplement for stressful events like single-cell passaging. And then there's Essential 6 Medium, which does not contain growth factors and can serve as a great basal medium for differentiation or other PSC applications. Now, expanding on a point I made earlier, being GMP manufactured, Xeno-Free, more consistent, and more cost-effective, the Essential 8 system has always lent itself well to an eventual cell therapy application, but we knew that there were opportunities to further tailor the product for cell therapy. As such, we now introduce the newest addition to the Essential 8 family, CTS Essential 8 Medium. This CTS version of Essential 8 Medium was designed to meet global cell therapy regulatory requirements. It reduces risks because it is rigorously tested and is animal and human origin free. In fact, right now, it is the only globally available animal origin free PSC medium. And then, like the rest of our CTS products, it facilitates regulatory filings with cGMP manufacturing and regulatory documentation. Finally, it does enable a seamless transition from the RUO Essential 8 medium because it uses the same 8-component formulation, though with animal origin-free or AOF components. Going deeper into the differences in terms of documentation, CTS Essential 8 does have a drug master file. As I said, it has a completely animal origin-free formulation and will have full traceability information and documentation on the various components of that formulation. As for QC, it does undergo the same functional testing using H9 ESCs over 3 passages. Although both have sterility testing, CTS Essential 8 has sterility testing according to USP. It undergoes qPCR mycoplasma testing and has stricter endotoxin specs. I'd say what is evident in all of these differences is that we did perform a regulatory risk assessment when CTS Essential 8 was being designed. We looked at the original Essential 8 medium, evaluated it against global regulatory requirements, and that is what drove the improvements in the formulation, the documentation, and the QC testing to fit cell therapy needs. At the end of it all, we are able to provide a PSC medium with a different intended use statement that should again facilitate your regulatory filing, and that is for research use or manufacturing of cell, gene, or tissue-based products. Obviously, a PSC medium is not used in a vacuum. It fits into a complete workflow, often stretching from somatic cell culture to reprogramming, to banking, differentiation, characterization. As you can see here, we have a complete and robust offering across the RUO Essential 8 workflow. CTS Essential 8, being very similar, has a list of compatible products and a workflow that basically mirrors this while incorporating CTS products that would better support cell therapy. And then altogether, what you would see is a seamless transition in the PSC workflow from RUO to CTS. And we'll go through this step by step. So if you're starting with fibroblast culture, the standard fibroblast culture medium contains FBS, and we do have GMP manufactured FBS, as well as GMP manufactured knockout serum replacement. As you might expect, serum replacement is more defined, and this one is more specifically used for PSC-related applications, though more for feeder-dependent PSC culture or differentiation. With further supplementation, it can be used for culturing fibroblasts, pre-reprogramming. Of course, for cell therapy purposes, we would recommend using CTS knockout serum replacement XF, which is based on that widely cited RUO product. Just the difference would be that this is Xeno-Free, and like other CTS products, it has more extensive testing and has documentation to support regulatory submissions. For the reprogramming step on the RUO side, we have the CytoTune IPS 2.0 kit, which has the highest success rate among non-integrating reprogramming technologies. For cell therapy, we do have a CTS version, CTS CytoTune IPS 2.1 kit. It's a really cool product. It is the first off-the-shelf reprogramming system designed for clinical and translational research. What it does is it replaces CMYC with LMYC for weaker transformation activity. It has no BSA in the viral dilution buffer, and it's produced in a GMP certified facility for consistency of the material. And like the previous CTS product, it undergoes extensive testing and has the documentation to support your regulatory submission. In terms of PSC culture or growth with CTS Essential 8 medium, it is compatible with Gibco vitronectin, which is the defined matrix that the Thompson lab designed for use with Essential 8 system. It's also compatible with Gibco laminin 521, which is also defined, but would be a more robust option, and it's great for challenging applications. Of course, for the best option for cell therapy, we do have CTS vitronectin, and that uses the same VTN-N variant that has been shown to support the attachment and survival of PSCs better than wild-type vitronectin. At this point, I'm sure you're spotting the trends. It has extensive testing and documentation. In terms of passaging in the CTS Essential 8 system, we primarily recommend non-enzymatic clump passaging with our GMP manufactured Versine solution. If you are at a stage where you need to use a CTS product or want to do single cell passaging, you can use CTS triple select enzyme, which has the same formulation as the RUO product, but has extensive testing and regulatory documentation. If you do perform single cell passaging with CTS E8, just like with Essential 8, please do make sure to use a ROCK inhibitor. We particularly recommend our GMP manufactured Revitacell supplement. For cryopreservation, our Xeno-Free and GMP manufactured PSC cryopreservation kit provides the best performance as it was optimized for PSCs. For a great animal origin-free option with the usual CTS benefits, we do have CTS Synthafreeze medium. If you use CTS Synthafreeze, we also recommend using Revitacell supplement post-thaw for optimal recovery. Now, I won't go into the details of differentiation since protocols and cell types of interest vary widely. So we do have a wide variety of basal media, serum replacements, supplements, and growth factors under the CTS brand. They all have RUO versions, and they all have the same or similar formulation, but offer the extensive testing and regulatory documentation that I've mentioned with the others as well. So those products and recommendations are summarized here. and this is the CTS Essential 8 workflow. Now, looking quickly at characterization, PSCs have traditionally used cellular methods to look at PSC marker expression and trilineage potential after after the reprogramming process, after extended culture, the number of gene editing, for example. These cellular methods are mostly immunostaining, but you can also do flow cytometry. But they're very qualitative or semi-quantitative, except when you go into that flow cytometry level. We do have antibody kits that facilitate these kinds of characterizations. However, molecular methods enable more comprehensive characterization in a more standardized and scalable fashion. These are very important characteristics when thinking about cell therapy. Therefore, along with the use of CTS products, if you are going to cell therapy, we recommend characterization with the pluritest assay for pluripotency confirmation, the TACMAN HPSC scorecard panels for trilineage potential, and the Caristat assay for assessing genomic stability in lieu of G-banding, which you'll hear more about when Lauren starts her section. So let me close my section with a reminder of 4 key points. First, with technical and regulatory expertise, CGMP compliant manufacturing sites, and a broad portfolio of cell therapy systems products, Thermo Fisher Scientific is a trusted partner in cell therapy. Second, Essential 8 medium is a widely cited feeder-free PSC medium favored for its minimal and defined Xeno-Free formulation. Drawing from that, we have our third point. CTS Essential 8 medium enables a seamless transition to the clinic with an animal origin-free formulation, extensive testing and regulatory documentation. And lastly, combining Essential 8 and CTS Essential 8 with the other products in the workflow, Thermo Fisher offers a complete and compatible set of RUO and CTS products to support your PSC workflow from bench to the clinic. And now I'm going to hand you over to Lauren to go over the application data.
Okay, in the second half of our presentation, I'd like to share some application data for CTSE8. First, we'll look at data comparing research use and CTSE8, and I'll outline how you can transition your cultures between these two media. Next, we'll look at long-term PSC culture. And then finally, we'll talk about scaling your PSCs and also reprogramming with CTSE8. As Joanna mentioned earlier in the presentation, CTSE8 contains the same 8 components as research use E8, but CTSE8 has all animal origin-free versions of these components. So to be sure that there are no differences in performance between these two media, we cultured PSCs for a number of verstein clump passages in both the research use and in CTSE8, and then we looked at some typical PSC characteristics. In the images on the left panel of this slide, you can see representative PSC morphology for each media. The PSCs here have the typical attributes that you look for. The cells are tightly packed, the colony edges are smooth, and they have high nucleus to cytoplasm ratio. In the right panel, we monitored confluency over time for PSCs cultured in both media. As you can see, the growth curves are comparable for research use and CTSE8. So, in terms of morphology and growth kinetics, both of these media perform similarly. Next, let's look at maintenance of pluripotency for the two media. For these studies, PSCs were cultured in both media for 20 passages, and then assayed for pluripotency using 2 different methods. The left panel shows results of quantitative ICC analysis. For both media, there is high expression of pluripotency markers OCT4, NANOG, and SOX2. The right panel shows the results of pluritest, which is an array-based assay that quantifies global gene expression. It includes markers found in pluripotent and non-pluripotent cell types. In the plot, PSCs cultured in research use and CTSE8 cluster close to one another and are within the red cloud, which is associated with pluripotent cells. The final PSC characteristic that we have compared between the media is trilineage differentiation potential. For this study, PSCs were cultured in both media for 20 passages, and then embroid bodies were generated from the cultures using Essential 6. The EBs were allowed to spontaneously differentiate for 14 days, and then we collected them and assayed them using the TACMAN HPSC scorecard. So a little about scorecard. It's a qPCR-based assay that is based on a reference panel of genes, and it includes markers for self-renewal as well as ectoderm, mesoderm, and endoderm. The top left panel on this slide shows scorecard results for undifferentiated PSCs that were also collected at P20. The pluses and minuses here show that these PSCs are able to self-renew and are not biased towards any of the lineages. Below there, on the bottom left panel, there are scorecard results for the EBs, which are negative for the self-renewal markers and positive for all three trilineage markers as expected. The scorecard assay analyzes a number of genes, and one of the outputs is an algorithm score, which is shown in the plot on the right. The takeaway here is that undifferentiated PSCs cultured in the two media have very similar algorithm scores, and the same is true of the EBs for both media. This implies that comparable performance in terms of self-renewal capability for the undifferentiated cells and trilineage potential for the EBs. So the protocol for transitioning your PSCs into CT8 is very simple. You can take your frozen PSCs that you previously cultured in research use E8 and then just thaw them directly into CTS E8. Or alternately, you can take cells that you're currently growing in research use E8 and then passage them and just recover them in CTS E8. So as we've seen in the past few slides, comparing the research use and CTS E8, you can expect a very seamless transition when you're making the switch between these two media. Next, I'd like to share some data showing that PSC properties are maintained in long-term culture using CTS E8. The ICC images shown here on this slide show maintenance of pluripotency markers OCT4, SSCA4, TRA1 to 60, and SOX2. And this is after 30 versine clump passages in the CTS formulation. Here, we show that PSCs cultured long-term maintain the ability to spontaneously differentiate into all three lineages. We cultured the PSCs for 20 passages in CTS E8, then generated EBs in Essential 6, grew them in suspension for 4 days, and then plated them down and allowed them to spontaneously differentiate for 21 days. So the ICC images here show staining for 3 lineage-specific markers, and this demonstrates that PSCs cultured long-term in CTS E8 maintain this trilineage differentiation potential. Here on this slide, we show further evidence that the PSCs are able to differentiate into 3 lineages after long-term culture in CTS E8, this time with directed differentiation using some of our GIBCO differentiation kits. From left to right here, we have ICC staining for markers of definitive endoderm, cardiomyocytes, neural stem cells, and dopaminergic neural progenitors. And lastly, a common concern for stem cell researchers is maintenance of normal karyotype in long-term culture. Here we show normal karyotype for PSCs cultured for 20 versine clump passages in CTS E8. The left panel shows normal karyotype by G-banding. And the right panel shows the results of karyostat analysis. So a little about karyostat. It's an array-based assay that allows for digital visualization of chromosomal aberrations. And it has a resolution that is similar to G-banding. This karyostat plot has chromosome number along the x-axis and then copy number on the y-axis. So when your PSCs have chromosome gains or losses, there's a spike in the blue probe signal that would project above or below the normal copy number range. However, as this plot shows, after 20 passages in CTSE8, we did not detect any chromosomal aberrations via this karyostat assay. So the takeaway that I'd like to leave you with here is that you can have confidence when you culture your PSCs long-term in CTSE8 that they'll be ready when you're ready for your downstream cell therapy applications. So in the next section, we'll go through a workflow for scaling up PSCs in CTSE8. In this workflow, PSCs were cultured on nunc plastics with increasing surface area. We started with a 60-centimeter square dish and scaled all the way up to a 2-stack nunc cell factory system, which is actually a 20-fold increase in surface area. For this expansion, we recommend CTS citronectin for your matrix and then CTS triple select for passaging. So using this combination of CTS E8 and nunc plastics, we were able to scale up to 370 million PSCs per 2-stack, while also maintaining normal morphology and pluripotency. So in this final section, we'll look at reprogramming of fibroblasts using CTSE8. This first slide shows a completely Xeno-Free workflow for reprogramming fibroblasts using the CTS cytotune reprogramming kit. In the first part of the protocol, cells are plated and then transduced in a Xeno-Free medium on a collagen matrix. The components for the Xeno-Free media are shown in the blue box. And if you're interested in the exact recipe, it's available on our website in the user guide for the CTS cytotune kit. So at day 7, the cells are harvested and replated on either vitronectin or laminin 521. And the day after, the medium is switched to CTSE8. And after this switch, emerging iPSC colonies are seen by day 12 and are ready for transfer within 3 to 4 weeks. Our internal differentiation team developed the Xeno-Free media that was described on the previous slide, and they did this by screening a number of media candidates and then choosing the formulation that best supported transduction efficiency, fibroblast growth rate, as well as reprogramming efficiency. They found that this Xeno-Free medium also supports growth of primary fibroblasts that they isolated from skin punch biopsy. They used this medium to culture and expand human fibroblasts from 2 to 3 skin pieces. And the resulting fibroblasts were found to have normal karyotype. In the experiment shown here, fibroblasts were reprogrammed using the CTS cytotune kit. And if you remember from the workflow slide, there is a media switch on day 8 to PSC medium. In this case, medium was switched to either research use or CTSE8 for comparison purposes. 18 days after transduction, reprogramming efficiency was measured by staining the colonies with alkaline phosphatase. And as you can see from the plot, reprogramming efficiency is comparable for both media. The team was also able to derive several new iPSC clones using the CTS cytotune kit with the CTS Essential 8. In the next few slides, I'll show how they assay these clones to confirm pluripotency, differentiation potential, and normal karyotype. The pluriTest plot here shows the new iPSC clones clustered within the red cloud, which is associated with pluripotent cells. The team used scorecard analysis to confirm that these clones have the potential to differentiate into all 3 lineages. And then finally, the parental fibroblasts and the new iPSC clones were found to have a normal karyotype by both G-banding and by karyostat. So in summary, we've shown that the transition from research use to CTSC8 is easy and seamless. And you can expect comparability in terms of morphology, growth kinetics, pluripotency, and trilineage differentiation potential. Also, PSCs cultured long-term in CTSC8 maintain characteristics of healthy PSCs. Scalable PSC expansion can be achieved by coupling CTSC8 with the NUNC cell factory system. And finally, CTSC8 medium can be used to reprogram fibroblasts in a completely Xeno-Free workflow. Okay, now we'd like to open up for questions.
Thank you, Lauren and Joanna, for your informative presentations. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Answer Question box located on the far left of your screen, and we'll answer as many of your questions as we have time for. So let's get started. Our first question is, why did you use triple rather than versine in the scale-up experiments?
Okay, yeah, that's a great question. So when you're passaging with versine, after your incubation step, you remove the versine solution, but the cells remain attached to the plate. So in order to remove the cells, you'll need to flush some media over the top of basically over the top of the well. And that's really hard to do when you're working with one of these cell factory systems, which is basically a multi-layered flask. So when you're passaging with triple select, basically the cells come off the surface of the plate into the triple select solution, and they're easier to remove. So that's basically why we use triple select instead of versine. It's also easier when you're trying to count cells and seed a certain number of cells into your experiment. And it's also helpful when just to get more even seeding of cells across the flask. One thing I do want to mention is that E8 is as we've spoken about in length, E8 is a pretty lean media system. So we do recommend versine for just when you're doing general culturing for long-term culture. It's gentler, and stem cells generally like to be passaged as clumps. So you can use triple select for maybe 2 to 3 passages as long as you're including a ROCK inhibitor like Reviticel. But we don't recommend long-term passaging with long-term single-cell passaging with triple because it's stressful for the cells and you might end up with karyotypic abnormalities. So thanks for that question.
Our next question is, now you said that you need to think about ancillary materials as early as possible. When do I need to use CTS products?
I'll take that one. So seems that they're asking if you're using, say, for Essential 8, for example, when would you need to switch to CTS Essential 8, right? That's a good question. There isn't a hard and fast rule to that. Like I mentioned before, the earlier the better because you know that all or more of your data pertains to the reagent that you will use for what will be the final product. If I had to draw a line in the sand, I would say that you would at least want to do it when you create your master bank. And you might still be in early development, but when you create your master bank, that master bank is where you will draw your final product from, even at the clinical stage. Whatever you use in the master bank or to make the master bank will touch the cell therapy product. Therefore, what you use there is going to be under regulatory scrutiny, will actually influence the safety and performance of your product. So based on that, I would think that you would want the best and safest and cleanest and most well-documented option that you have at that point, which would be the CTS product. So that's where I would recommend it.
Now, our next question is a two-part question. I'm interested in the curiostat test. How do I use that, and do I need to have a microarray?
I can take that one as well. Yeah, sorry we weren't too clear on that. So all of the molecular tests that we described have reagents that you can purchase and use in your own lab with compatible equipment to analyze your samples. So qPCR machine for scorecard, and then microarray for pluri-test and curiostat. So we do recognize that not everyone has access to these, and we offer these as services as well. There's a website you can go to request a service, and your account manager or your technical sales specialist can assist you in getting these services as well. You have anything to add to that, Lauren?
No, I think you summed it up pretty well.
Okay, thanks.
We are getting some great questions in today, so let's continue with a couple more. Is there a protocol available for the Xeno-Free reprogramming?
Okay, I can take that one. Yeah, the protocol is available on the Thermo Fisher webpage for CTS Cytotune. So you can find that protocol there. It also has some information for reprogramming other cell types, I think PBMCs, T cells, CD34 positive cells. One thing I'd note there is that the protocol mentions only the research use E8, and that's because that product was launched before we launched the CTS E8. So we know that it's compatible, even though it does mention the research use E8. And actually, that is the same for a lot of our product literature and protocols at this point, just mentioning the research use E8. But based on our work with both media, we expect that CTS E8 can be used in the same way as research use E8 for the applications in our product literature.
I'm not using E8 currently. How would you transition cells from a different medium?
Okay, I can take that one too. That's a really good question. Unfortunately, we haven't really done much testing for transition from other media systems to CTS E8 specifically, but we have done a lot of this testing for research use E8. So the thing to remember is that E8 in vitronectin is a lean media system, and it's also an AOF formulation. So if you're transitioning from a richer media system that could contain animal origin components, especially BSA or HSA, you are probably going to want maybe an intermediate step where you might passage on onto a bit of a richer matrix, such as recombinant laminin 521, which we do offer, and it is an AOF product. So if you do that for the first few passages, that'll help your cells. While you're making the transition. So that's what we would recommend there.
I do want to add something there. That is what we recommend for the best results. We do also have published protocols on our website for a transition that doesn't involve laminin, but this is again still involving the research use Essential 8 medium. You can take a look at that as well. It has guidance on transitioning from say a feeder-dependent culture or a richer medium, and this would probably be up as well, given the similar composition and performance of Essential 8 and CTS Essential 8.
Well, that's a good point, Joanna. Thanks for adding that.
And it looks like we have time for one more question. Can you tell us how we can get guidance to avoid pitfalls when going to the clinic, and who do we contact?
Yeah, I think this might be referring to earlier in the talk when I was talking about our experts and how you have access to them as resources. So that's a very good question. Technical support is a valid way to start, and they're very accessible. You have their numbers available on the internet. Depending on your question or what you need support with, they may have the answer. And if not, they will very easily pass it on to the experts who can go into deeper kinds of questions for our CTS customers. The other way you can reach us is through your technical sales specialist, who can also answer some questions or pass it on to the experts if it's something more complicated. In general, I would say that if you are interested in cell therapy, especially if you're maybe at the point where you think you might be interested in CTS products, even if you don't have questions, it's not a bad idea to have a conversation with your technical sales specialist so that they're aware of your needs and they're prepared to help you.
Thank you, Lauren and Joanna. Do you have any final comments for our audience?
No further comments from me. I just want to thank everyone for joining us on this webinar.
Thank you again, Lauren and Joanna, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Thermo Fisher Scientific, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand through April of 2019. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. You will now be redirected to our upcoming webinar, Cell and Gene Therapy Solutions, Enabling PSC Translation Workflows. Here you will have the opportunity to register for this live interactive webinar, as well as links to view past webinars on demand. Until next time, goodbye.